Okay, so we're in week 4 tasks now. Jump into the student work folder. We're going to be working with materials in this session. Now, the guidance wants me to start off by creating a master material. I've already been to an extent doing that already, but I've got it separated for my emissives and my metallics. But what I'm going to do is I'm going to adapt the emissive to compile it all into one, and then since there's fewer metallic instances here, I'll just replace those where they're used on the AI. So we'll jump into emissive, and before we actually do anything there, I'm going to rename this to master. And then we're going to open up the master here. And the way that I've been handling the emissive is we've got the albedo, and we're using that directly for the base colour, and then we're multiplying it by a scalar parameter, which is emissive value, and using that for the emissive colour, so that we're using the albedo and we have a scalar that we can control. So we'll leave that as it is for now, and we're going to use a scalar parameter for the metallic. And I've just unhook this for now. We'll keep the base colour just so we can see what this is doing. So the metallic is how metallic the object is. Is it metallic or is it not? So we'll call it metallic for now, just so we can see. Then we've got specular. We'll have another scalar parameter. Call that specular. And that's this, typically white. Let's just unhook this for a minute, and we'll just get a 3 vector, plug that in there, set this to something that's a little bit easier to pick this up on. Like that. So we've got the specular light. The specularity is driven by the specular value here. We've got roughness, going to have another scalar parameter, and we're going to call this rough. So this is how rough is the object, either completely smooth or matte or anything in between. So I'll set that maybe 0.3 for now. Anisotropy is so the way that the specular light bends around the object, the way that it stretches, that's driven by anisotropy. By default that's 0.5, but if we do want to control that, we can give it another scalar, or we can drive it with other maths. It's quite a niche use, so we don't need that right now. Emissive colour we're going to reconnect in a moment. Yeah, I think that's everything that we need connected in there. So I'll hook the emissive colour back up there, and we'll connect the base colour and get rid of this. Straighten that up with Q. So that's the master material ready. So I'm going to turn the metallic off at standard, turn specular off, turn roughness off or on, leave it on I suppose for for an emissive. Yeah, so that's the master material setup. I'll hit save on this, and it might mean that I need to go in and mess with the instances. Nope, everything seems to have kept its settings okay. So we can right click on this and create a material instance, and that's these that I've prefixed with MI for material instance. And if we open any of these up, we've got all these values here that we can now turn on and mess with, and we can turn the emissive values of these up. Let's make that actually a emissive green. Yeah, that's quite nice, quite bright. Yeah, nice. And again, that's all driven from this master material, so any changes we make here we have available to us in the instances, but anything that we want to drive within the master material in an instance, we need to create a parameter to control. So now that we have a master material, we're going to make a material for a decal. So we're going to call this m_decal master. We'll open that up, and inside here we're going to change the material domain to deferred decal, make it translucent, and I believe we can just pull in a texture sample parameter. Texture sample parameter, this will be albedo. Okay, so we've been provided with a texture to use for this, which I've downloaded and installed into the project. It's just a little arrow. There it is. And we're going to use this in the base colour and in the opacity. Oh, hang on, no. We're going to use the alpha for the opacity, of course. Just straighten this up. That's not what I wanted it to do. And because this is a deferred decal, we should be able to just drag this out into the world. Like that. Let's just have a look on these on the side here. We've got decal size. What we're going to do is unlock that and set the X value to 1, because as it stands, as it was, if I grab something like this and just drag it over, and then if we undo that change, set that to like 100, you can see it stretches up the object, and that's because the bounds box is trying to draw it up there. But we set that to 1, it's just a small area, so we don't get any of that texture stretching up adjacent objects. And get rid of that. There we go, a decal. Okay, so next I've taken a copy of the lamp mesh that was provided, and I've called it lamp blinking. I'm going to make the light flash inside that. So I'm going to open that up for a minute. I'll just close these other materials, minimise that again. I'm going to jump into the materials folder and make a new material, m_flashing light, and I might actually make this a master. This might actually be quite useful somewhere. So we'll call it flashing light _ master, so that we can identify that faster. Okay, so for this we're going to use two vector parameters. I'm going to have albedo 1 and albedo 2. And if we take quite a nice, do it on the lower one actually, quite a nice bright blue here, and we take something a bit dimmer on the scaling, like there maybe, yeah, something like that, and then we'll lerp those. Linear interpolate. Just apply that for a moment there, see if it, don't know why this is so big compared to this one, but doesn't matter. So we'll lerp in those two colours, and this is going to feed into the emissive colour. And what we want to do for the alpha, we're not going to have it on 0.5, we want to take time, and then we're going to use sine plus 1, and then we'll divide that by 2 and use that for the alpha, and that should give us a pulse. Straighten those up like that. And now I can make instances from this. You can see that it's actually flashing here. So now I can make instances from this. So create instance. This is going to be not mi material instance flashing lamp. And now we can open that up and we can adjust these colours as we need to if we want to, and we can open up a flashing lamp and we'll go and search in here mi underscore flashing lamp. Now we have it on the mesh. So if we pull one of these into the game, copied flashing lamp, we can see that there, but that's not all that bright. So let's jump back in. We'll go into the master again. I'm just going to move all this along a little bit, and after here we're going to multiply, and we will multiply by another scalar parameter, and this is going to be emissive value, and I'd say maybe 10. It's a little bit brighter. And then in flashing lamp, that should carry over. We'll save here too. Yeah, that's much better. There we go. So one final thing that we can do in this, we can come over into the master again, Now if we move time over here and multiply here as well, we can come off this and add another scalar. I'll call this timescale. And if we set this to maybe 3 or maybe 2, less of a strobe warning, you can see that's applied to the lamp now. And again, if we jump over into the materials, we can open up the flashing lamp instance and turn these on, and we could increase the emissive value, we could increase the time scale so that it's really blinking quickly, and we can do that per instance. We'll just reduce that again for anybody that has issues with flashing. There we have it, nice little lamp. So now we'll look at creating an explosive barrel that flashes before it explodes. So we'll go into, I think I stored, no we don't use an AI, we'll just have it in blueprints, and we'll make a folder and call it props. And then here, create a new blueprint class, create an actor, this will be BP underscore explosive barrel, and we'll open that up. Oh, well, we're going to give it a static mesh. We'll set this to the barrel, and I'd like to make it quite a big barrel, I think, so let's just compile this and we'll drag one of these out so that we can see how big it is. So we'll open this up and let's try 2 on the scale all round. Compile that. Let's see what that looks like in game. Oh, we're over here somewhere. Yeah, that's quite nice, and we can shoot at that quite easily. So, we'll open this back up, and we will go into the construction script, no, the event graph for this, and we want on event any damage. We're going to get a do once. And off this we're going to get a timeline animation. And this is going to be the flash. And then when this finishes we'll destroy actor. Just straighten those up. So inside the flash we're going to set the length to 1 and add a track. Float track, and we want a keyframe at 0 with a value of 0. Then what's the best way to do this? Add another keyframe with a value of 1 at 0.25, so it takes half a second, we'll say, for not quite sure how to get this so I can see all of the graph, but that's fine. So we'll add another keyframe at 0.5, and this will be value 0. Add another keyframe, so we'll go 0.55 value 1, now we'll go 0.6 for 0, 0.65 for 1, 0.7 for 0, 0.8 for 1, 0.85 for 0, so that's 3 blips. There we go. Hang on, what's this? 0.7. No, we need that 0.75. 0.8. Much easier when you can see it. So if we say 0.85 for 1, and then it will maintain that brightness till death. So compile and save. We'll jump back over into the event graph. Notice this hasn't changed here, so probably won't come over here. Just rename this to flash. And there we go, we've got that value there ready to use. So now what we want to do is jump over into the materials. I want to create a new material. We're going to call this m_damage flash. And then inside that we want 2 vector parameters. For albedo 1 and albedo 2. We're going to feed the base colour straight in. And then we're going to take the second colour, which will be red. So that's 0. Yep, just red. And then we'll be layering this. Linear interpolate. Just bring this out a bit. And the alpha, we're going to call this flash level. Scalar parameter. So this is a default value. This will obviously be driven as a dynamic material. Give ourselves a bit more space there, and this can go into emissive colour. And we can save that. Okay, so with that we're going to jump back over into the explosive barrel now. We're going to go into the construction script, and we want the static mesh, and we're going to create a dynamic material instance. I just want to check on the barrel what these are. So the element index here is referring to the elements for the materials here. So let's make the band inside it flash when it takes damage, and then we can change this to maybe a metallic red so that you can tell it's a explosive barrel. So we're going to use this and promote it to a variable, and this is going to be the flash material. Straighten the connections there. And obviously in the source material we're going to get the M underscore, let's just search for flash, yeah, M underscore damage flash there, and that's the material that we'll be using. So now we'll compile that and we'll jump over into the event graph, and we can pull this down because what we're going to be doing is getting this flash material and setting the scalar parameter value, and the name is going to be flash level, and that's going to be driven by the timeline animation on update, so it uses that to drive the animation. Okay, so let's just see if that works. We'll compile, hit save as well, minimize, and we can drag one of these over here by the player. And that's got a strange colour for some reason. Let's have a look at that. Maybe I should be setting this to more of a greyish colour to match the barrel as it was originally. We'll see in a moment. Explosive barrel, viewport, static mesh. Yeah, I'm not sure why that's... hold on. That's the element that we want to set with the flash material. Yeah, and then element 0 should be the metallic red. Compile, that's much better. So now if we try that. Yep, it flashed, it blew up. Just so that we can see that a couple of times there, let's drag a few out. Cool. So that's using a dynamic material on a explosive barrel. Obviously we'd add an area of effect around that to apply damage to everything within range, and we'll be using particle effects, but I'm pretty sure that the guidance is leading into that, so I'll try not get too far ahead of myself. So something that's been brought up in the guidance is for the enemy AI. If we just take the parent enemy, we can't actually rotate these in engine, we're only rotating the gun. So just Control Z with that. What we're going to do is open that up and go into the construction script, And then we're going to take the static mesh, which will be the tank body. And what we want to do is set the world rotation. And then we're going to get the capsule component. And we're going to get the world rotation of the capsule. And drop that into there. And because the construction script runs like before runtime, that'll update this in engine as well. So if we just drop this in now, oh, we've still got it here, we'll be able to rotate the enemies and actually position them if we wanted to do that. And if we spawn them at a specific orientation from the enemy spawners, when I build them for the wave defense, they'll spawn facing the correct direction as we want them to. And because this is the parent enemy, everything else is a subclass of this. So that'll carry down. Okay, so next we're going to be working with making some Niagara particle systems. So we're going to jump into the student work folder and into Niagara. I've already got some that I've been creating, but we'll get into the weekly task content before I start delving into the stuff that I've been doing beyond that. So what we're going to do is take a Niagara system, and we're going to take the fountain emitter, and we're just going to call this NS for Niagara system _ spark test, and we'll open that up. And here we are. So to start off, we're going to uncheck the spawn rate, and we're going to add a burst instantaneous on this. And we're going to make the count 20. The time we're going to set as 0.5. And we're going to have I'm going to set this to 0.8, so they're quite likely to spawn, but there's a 20% probability that they won't. So now we're going to go into the shape location, and inside here we want to make sure that the primitive we're using is a sphere. We're going to change the radius to something more like 20. The distribution we're going to keep at random, and the hemisphere distribution, so we want it in the top 20% of the hemisphere, so we're only spawning at the top for a burst of sparks. Okay, so now we're going to go into add velocity, and we want to ramp the maximum up to something more like 2000. Just hit save on this. Okay, so now scale colour, we're going to hide that, and instead we're just going to get colour. That. And then we can use this to get a, if it will let me, there we go, colour from curve. Okay, so now we're going to set these values here to something more electrical looking. Something more like that. Yeah, I like how that's looking. I actually circle around again. That's cool. Okay, so now we're going to jump into initialize particle. And maybe up the lifetime max on some of these so that they last that little bit longer. Maybe make this more like 1.6 just to get a little bit more life out of them. We could mess with the scale sprite size. There's particle update here, so here we go, scale sprite size. So we could add keyframes to this. There we go, add a key. Just paint something in here. And see what that's doing. So now they're going up in size and then they're coming down in size as they reach the end of the lifespan. Maybe spike that up even higher just to see what that does for us. Yeah, that's quite cool. Quite a nice effect. And that's pretty much the guidance for the sparks. We can have a look at that in the game here. So we'll just see what that looks like. There we go. And we just burst out with sparks. If I just deselect and hit G so we can just watch it doing that. That's quite nice. So, turn this on so I can see again, we'll get rid of that. Next we're going to make another Niagara system, but this time we're going to be using an omnidirectional burst. If I can just find that. There. And we're going to call this NS underscore projectile hit. Now I'm going to have to make a few of these, so once I've got one of them built nicely, we'll be able to copy this and just do another for the colour, just switching the colour values. But we'll set this up as the guidance shows. Okay, so we're going hide scale colour and just have colour. And then we're going to put it on a curve. Bring this right down in here. Something like that. So this will be 0.1, 0.1, 0.1. This will set to like 1000, 1000, 1000. So that's 0, 1. Yeah, we're probably okay with that. Okay, simple stuff. Now that's working, we can jump out of here. Just let that finish saving. And we'll go into the blueprints, projectiles, and we want to do this on the enemy parent and the player parent projectile. So player projectile parent, and we have enemy projectile parent. We'll start on the player. So before we destroy actor here, we want to spawn system at location, and we're just going to get actor location. For self. Yeah, that'll do it. So we want ns underscore particle hit, I think, projectile hit. Yep. Good stuff. We shouldn't need to mess with rotation and scale, but if we do, we'll mess with that when we come to it. And, I mean, we can just copy that and paste it in here, because this will be the same code in the other projectile. Okay, we'll compile and save that, and we'll save on here too. And we'll just have a look that that works. Okay, let's have a look if it works now. Yeah, that's quite cool. The only thing I'd say now is that we want to match that colour up with each projectile that we're firing. And I'd even go as far as to say we could make that hit look a little nicer than that. But that's functional, and it's some feedback showing that the projectile has hit wherever you're shooting at. Okay, so it seems that the second part to this video didn't record properly while I was recording it. I'm not sure why, but the videos just didn't seem to save. So I'm just going to go through and recap what was missed, what I covered as a part of the fourth set of weekly tasks. So I believe we were up to the flamethrower. We were just about to build a flamethrower. So we were provided with guidance for the first fountain using just the basic sprite. I've been using my own material for this, which I will open now. I did actually make this in the video, but we can't complain too much. So, flamethrower sprite is an instance. Energy trail is what it comes from. So this looks a little bit daunting, but it's not actually all that complicated. So we've got two colours for the albedo, and we're getting a texture coordinate, masking R, which is giving a gradient from left to right, or right to left, it's one of them. Using a power to increase this, hitting saturate, and then we're lerping these two colours. Then we're multiplying that by another function that's going on. So if we ignore the dynamic parameter for now, same with the particle colour and time down here, they're being used in the particle effect and being exposed to adjust these settings. So the texture coordinate is basically using a panner to tile a texture that I created, and I'll open that up in a moment. And then out of this texture, on the red channel, we're multiplying by a radial gradient exponential, and that's, if I switch over to a plane, that's fading the edges of this as a sprite, and just like giving us a nice little particle shape. Then out from that we're multiplying with the albedos, and then we're multiplying again by particle colour for both the emissive colour and the opacity, just so that we can drive these through Niagara. So yeah, nothing overly complex there. If I just open up those textures so that I can show those, these again are nothing crazy. I just went into Photoshop. So for this one I went into Photoshop, got a black background. I used a brush, a smooth brush with a fade, and I just drew lines across the screen, swirling lines. And then I offset the image and connected those lines up so that they're actually tiled. Then I went over it all with a hard brush, but a smaller brush, just to get these central lines in. Again, offsetting to get the tiling effect. And then I went over the whole thing with a smudge pass, just smudging these lines in to get a little bit of texture. And that is all there is. It's nothing more complicated than that. The blood noise uses the same process, but I started this by rendering clouds as an effect in Photoshop, and that gave me basically like predefined paths that I could follow, and it's also got this nice textured effect. But it was a little bit dark, so I went over all of the lighter areas, just adding a little bit of white on a low opacity to do like a lightning pass. And then I went over again with a small black paint layer, just to get these sort of smudges and holes in the texture. So this is quite good for viscera. But I found that it gives quite a nice effect for fire, especially when it's used alongside the energy noise, like was what's going on here. So if we just isolate the original fountain, this is the energy noise texture, whereas this is the blood noise texture, which alone, both of them look a little bit subpar, but you put them together and you get this really nice effect that's going on, especially with the blood noise being used as a darker tone. Then we just have a couple of these. This should be emitting sprites, but isn't. I want to have a look at that at some point, but it's not too important right now because the effect is still nice. But this is just a copy of this, which is emitting bright sparks, basically, just to complete the effect. Now this has been implemented as a weapon, so if I just jump out here and we go to the blueprints, weapons, and we've got the flamethrower weapon there. Again, it's nothing overly complex going on here with this. So event triggered, we're using the branch and cooldown like we used before, except we're using a multi-sphere trace for objects, and the object type as a variable we've promoted, and that is set to enemy. So we're looking anything that is classified as enemy in here. And we'd obviously have to change this variable if we wanted to add a flamethrower to the enemy AI. And we're getting the direction arrow from the tank, getting the world transform and using that as the start location, and then for the end location we're using the forward vector of the tank, the arrow. We're multiplying that by 500, and that's because I tested for the length of the particle effect, just to get a realistic sort of range on that. So that multiplies by 500 and then adds on to the world transform to get the end location. And I've set the radius to 30 just to give us a little bit wider of an area for that circle that's being drawn. It just matches up with the flames better. Then out of the hit results, we want to loop through those to find all of the hit actors, and then on each we're going to apply damage. And once completed, we're going to set the cooldown again, run the timer by event to reset cooldown, and set the cooldown to false again so that we can continue this chain, and that is how we're throttling this from firing, just to so that we're dealing consistent amounts of damage over time, and that is obviously set by the cooldown, not the cooldown, where's that set? Here, sorry, the timer by event, the time that we've got set in here. Moving on from here, the final thing that we did was create an explosive barrel. So if I can jump over to it's going to be in props. I created this barrel. If we just jump out. So in here we've got event any damage, and we're calling do once. We've got a timeline animation that's just flicking between 0 and 1 to give us 1 long pulse, 3 short pulses before stopping at full value. And we're using that timeline to set a scalar parameter value on a flash material, which is a dynamic material. Off finished, we're spawning a system at the location, getting the actor location of self, and playing a sound at location, which is the explosion sound that I've imported into the project. The system, of course, being the explosion. I'll pull up the Niagara effect in a moment, and we destroy the actor. So if I can pull open the static mesh, the dynamic material we're setting, yeah, the flash level, so we're changing the parameter flash level inside the flash material. Yeah, so there we go. Inside construction script is where we're actually setting that flash material. I was just trying to remember where I put it in this blueprint. So we're taking the static mesh here, using the elements here, so we're getting the element index 1 because we want the line and the little point at the top, and we're setting the flash material there. Now if we go into the Niagara system for that, so this is using a single mesh render, and it's increasing in size before fading out using a color curve, and that just spawns, increases in size, fades away, despawns, and we've got a couple of upward mesh bursts for rocks as a mesh render that sort of come out glowing, fade to a greyish and disappear. And then we've got the smoke that comes out quite bright white and then fades out. I haven't added any of my own materials to this yet, because I do intend to make explosions that are suitable to each of the projectiles, because some of the projectiles I'd like to make explode. So I am going to be coming in and making more of these particle systems. So for this I stuck mostly to the guidance provided, as I feel like I've more than covered what's being provided here in the projectiles I've created myself, which I will open up now. I have two real types for these. We have the projectile energy, which is the small version, and this is a mesh render for the ball, the actual projectile ball itself, and that's tiling, that's using the material similar to what I showed before. I should open those two. So we have the energy projectile material here. Now this is doing much the same as before, except rather than using the R channel on a mask to give a gradient fade, we're using a Fresnel to give that fade from the outer edges of the material. Down here we're still doing a very similar thing with the tiling texture. This one in particular is set to the energy waves, but we're also using a panner to drive just a noise texture to affect the world position offset, and what that does for us is gives us this wavy outer edge to the projectile, and it just looks that little bit nicer. It looks like it's actually burning. The glow is literally just a single sprite glow particle inside, just set to low opacity, just to add a little bit of depth to the effect. The speed effect is another mesh render working exactly the same as the ball, except that's using the blood tiling material, and the mesh has been affected to be stretched along one axis just so that it creates this nice effect as the tile runs along it. And then the fountain is just a sprite renderer. I've increased the shape location to match up with the ball, affected the sizes of the particles until it gives us quite a nice effect, and I think the end result's quite cool looking. And this is the basic. So the more complicated version of this is using I've just pulled this the energy speed lines, like I say, working essentially exactly the same as the energy trail there. And if we open up the systems again, I get the energy trails. This is the big fireball or big energy projectile. Now the major differences with this aren't anything crazy. We've got basically a bunch of ribbon renders. So we've got 3 longer ribbons that are generating, which are these 3. We have one, and they're set to be quite small ribbons with quite a stretched out tiling to give us essentially flames as those textures pass by. Then we're doing something similar for the center, which is this larger one. We're generating much larger sprites for that, and I've set the tiling just so that we're getting a good realistic flame effect from this. And then the smaller, faster lines are the burst, and they are set to really small tiling over quite a large particle with a short lifespan, just so that we're getting this little burn off at the back of the projectile. So picking back up with the explosions, the explosion particle effect for the explosive barrel, we've covered how the code works, we've covered how the particle system works, so let's actually put one of these in the level and shoot at it. Just throw on that. Nice. So, exploding barrel. We can shoot it, it makes a boom. I've also added this to the parent enemy, mostly because it's really easy to switch out once the code is in there. We just literally switch over the particle effect and change the sound effect. I believe both of which are exposed, if not I will expose the particle system. No, it's just the sound effects I think that are exposed here. But yeah, inside here where we've got the death logic, we're setting as dead, and we're playing a sound at location, getting the actor location for self, which really I don't think we actually need that there, so we can just get self. And then we're spawning system at location for the explosion particle system, and just before we destroy the actor. So if we save that and we throw in, I don't know, just one of the swarmer child enemies, and hit play, it'll move around, it'll shoot at us, but when we shoot at it, we can now destroy it. And not only destroy it, but make it look cool. So yeah, that's where we're at. That's the end of the 4th set of weekly tasks. That's all of the content provided for those weekly tasks, so everything now is going to be turning this into the wave defense shooter. So I will be getting on that in the next set of videos. Catch you next time, guys.
Nebulous.